I would like to introduce Noe Dettori. He is a platform architect at Miner and Cache. He has over 14 years of experience, software engineering experience. In his past 5 years as a senior cloud Java developer, he has focused on the entire Hadoop architecture, or cloud computing architecture, working in utility, ingest, storage, MapReduce, query, and UI. Noe Dettori.
How's everybody doing? Everything's vibrating up here, so sorry. Yeah, it's his last talk of the day. The only thing between you guys and happy hour is me, so I won't drown this out for you. But yeah, so as I'm sure you can see the slides, Accumulo Client Failover. It says it all. Yeah, so yeah, that's about it. Just learning. Okay, that is what got me this speech, and here's the outline. So basically, a little trailer. Yeah, so basically, just talking about Accumulo and multiple data centers in the ecosystem today. How does that affect clients? Going to cover our Accumulo Client Failover API that came out of this. It's the main focus of this talk, and how that client is used, and how Accumulo Failover client can also be used with third-party existing libraries. So yeah, so quick question. Here, who uses Accumulo here at work? Okay, most everybody. Here, who has multiple data centers they have to contend with? Awesome. Awesome, awesome. Okay, so yeah, basically, as most of you are probably aware, Accumulo 1.7 had something come out with the feature of replication between two data centers. Basically, the way replication works is it takes the write-ahead logs, and at first, there's two ways based on this write-ahead log. At first, it was based on size. So when that write-ahead log hit a certain size threshold, it would then be marked for replication. Taking a step back, replication only happened in Accumulo on the tables you specify. So once you specify tables, and then it hits the wall hits a size threshold, then it would be marked for replication. Second feature they just added was, I'm getting blown up for, was time. So my customer was like, yeah, replication sounds great, but it's no good for me on the fact that, you know, all the use cases are different. Some users might just persist a very small amount of data to Accumulo, never hitting that threshold. So until we had this time-based feature, which defaults to 24 hours, we changed it to an hour. Replication was useless, but now, since it is, we're using it. We've been using it for probably, I just deployed it into production like a month ago, so we really haven't got to see all the haves and have-nots of it yet, but it's definitely working, and we're going for it. Obviously, with that said, you can configure it different ways. I think in this picture is showing just one data center to another, so primary to peer. You can also configure it with data center 1 back and data center 2, so basically only the writes that happen to that particular data center will be replicated to whatever configured data center. So that's kind of pretty cool. You can do like master, primary. You can have, I've seen pictures of having 3 data centers. So yes. But prior to this replication feature, alternate architectures, and probably most people are still doing this, is that your clients would do your writes to both data centers. So it seems kind of problematic because there's like many users of Accumulo, right? And if you have to support 2 data centers, like everyone's writing to 2 data centers. So as Accumulo evolved, it came with replication, which is obviously answer the problem here. Also, you might see NiFi. For those that have dealt with NiFi, as it comes from the same parent as Accumulo does, NiFi has pretty much been configured the same way. Data will come in, and so to have that data in both data centers, we'll replicate it to 2 different or more places. So these are kind of questions that came out from my customer. Was like, that's great, we got replication now, but we've been pushing to both, but how about the clients? How about the users of Accumulo? and these data centers. And there's, like it says, there's no way to know like the active data center from a client perspective. There's no way to fail over. So if a catastrophic event is to happen, there's no automated, seamless way for clients to roll over to that data center. A big thing that we've been experiencing lately is, since all these upgrades from like 1.6 to 1.7 and various other products, we've had to have a lot of outages, a lot of data center outages. So basically, we have to then coordinate with our clients saying, hey, stop persisting data here to data center 1, persist to data center 2, and so it's just a lot of maintenance headaches and a lot of frustration for the clients because they're having to adjust their flows. At one point, it was like 3 days out of 5 in a week for like the course of a month, which just gets ridiculous. Yeah, so, and then at the end of it all, there's no catastrophic event. So the whole point of having like a backup data center is that if a catastrophic event happens, that you don't lose all that data. And there's no way for that to be automated at this point. So with those problems presented, we had some goals in coming up with Accumulo Client Failover API. Some of those goals were basically, obviously, just have an arbitrary failover. So for whatever particular reason, we can just automatically, seamlessly fail over to a particular data center. Another big thing is that we wanted the API to pretty much mimic what users are using now. So all like the instance connector, scanners, batch writers, batch scanner, all those tools that we use today to actually communicate, write, persist to Accumulo, we wanted it to be the same. So we didn't want the users to have to like learn a new API, learn, understand how it works. We're just like, let's just keep it the same. And then third but not last, basically we wanted to have like an event. So the users are using the same kind of feel of an API, but then when a failover actually happens, we want to give them the ability to kind of do some house cleaning. And we figured that if we throw an event, that'll give them the time to just do any maintenance or cleanup before their code is now persisting to a different data center. So here's kind of like the big, like rough picture of what that looks like. So yeah, so basically we have a client here in NiFi, and so they're writing to a data center 1. Data center 1 is configured to replicate to data center 2. Data center 2 is also configured to replicate back to data center 1. Basically, clients, they're controlled by which data center they talk to by Zookeeper. So using the failover API, the failover API consults Zookeeper and gets the active instance of Accumulo to use. And basically, yeah, so that's high-level picture there. So yeah, here's our initial release. So basically, like I said, Zookeeper is the controller and trigger of a failover. So with that said, like, there has to be something another piece outside of this API that would update and modify a Zookeeper. So what happens is Zookeeper is just keeping the current instance that we want to use to actually be using for the client. And then once that Z node is updated, it triggers a watcher. So basically we're watching that Z node, and when it updates, it creates what we call a failover event. And then basically that failover event trickles down through the API, and when you use the API, when you use like, let's say scanner or writer, and you just use one of the method calls, it throws a failover exception. At which point you would handle that exception, do your cleanup, and then just continue on work to the new data center. So yeah, here's kind of the design. So we kept a lot of things to look the same, and we kind of just had a failover in the front. I don't know if you noticed that. Some of the new interfaces we created was like a failover controller, which triggers a failover event, and created a interface failover handler and failover flag. Failover instance is implements Accumulo instance, and it's kind of a wrapper around the Zookeeper implementation of that. But it also implements the failover handler. And failover handler is kind of where the magic comes in, that obviously can handle a failover event. So what happens is the failover instance, it's just exactly like you're used to using a failover instance now. Usually you just pass in a couple parameters to your instance and you get a connector, and that's pretty much it. And then you can call the connector as much as you want, or you can use the connector to call as many badge writer scanners as you want. The difference is we kind of keep a handle on the typical implementation, and we use it as a delegate object, and we kind of wrap that so that we could actually update these objects. So basically, let's say you have a failover scanner, and a failover event has trickled down, that was triggered by a failover controller, trickles down to the failover event. Your instance is reinitialized, your connector is reinitialized, so the existing instance and connector you have are like good to go to the data center. And it triggers a flag, a failover flag into like your writers, scanners, all the things that are created by a connector. So when you use those objects again, it will then trigger the failover exception. So here's a little code example. So we have the Zookeeper failover connector, as you see, znode. So it looks pretty similar to what you should see as far as like getting connector. And then we have, so if you skip past the while loop real quick, and inside the while we have a scanner, which is created by a scanner, set range. So that should be like just boilerplate, like this is how you use Accumulo. In order to utilize this API and do the kind of cleanup, we have to kind of wrap in this while try catch, which is, if you can see, we're catching the exception that's thrown, and then basically it's just going to try it again, get a scanner, and set the range, and then if a failover doesn't happen, the second time around it'll just complete. So as I was as I was making unit tests for this, kind of testing all the use cases, testing all the badge writers and scanners, I was like, wow, this is like getting annoying with this like while loop and this try catch, and I was like, ugh. So we came up with this retriable concept. So basically just an abstraction around the try catch, and we used Lambda and kind of like functional program design. So basically, this is the exact same code from the prior slide, but it's a little cleaner using like retry, and then it just kind of does the same thing. Now I will say that this was like great for me as a user using the API, but so this logic doesn't work well for like users of this API, because what happens is your hands are being tied from actually doing like the specific maintenance work you need to do per your use case. I will say though that we have integrated this API into one of our products. Like, I don't know if you guys like AFS, like a file system. So we have my customer has a Accumulo file system API that pretty much just persists data into Accumulo, kind of like file structure. So we integrated this in there, and I will note that using this Lambda notation at that time really makes it like really clean code. So yeah, it's just kind of like a note on that. So last but not least, cool thing about this was it integrates well with third-party APIs. So basically, the whole point here is just we're now giving clients like a way not to worry about which data center they're pointing to. It's kind of handled by management. They use this API. Management can update a znode, and they'll just be writing to whatever data center or reading from whatever data center they need to be. So this also works like third-party APIs. So I just used, for example, GeoWave. GeoWave does like multi-dimensional like data persistence into Accumulo. And basically I just had an example here where just like the connector, so you pass in a connector object, right? Well, if you use like a connector that was initialized by the failover controller, you can just pretty much pass that same object in there, and then you get like the full like control and benefit of like failover, which is kind of sweet. So I think it's like super sweet. And then also I did this with Graphulo. Like, I think they did a presentation. I really don't know much about these guys. I just tried it out. But same kind of concept. Basically, if you got a handle on the connector instance and a third-party API can, you pass it in, then you kind of can get the full like benefit of being able to seamlessly, pick which data center you're going to. Yeah, I kind of made this a little more abbreviated, so sorry, but any questions? I know it's happy hour, so don't let me hold anybody back. Yeah. Yeah. Yeah, so Zookeeper, basically, it's just, right now we're just using it in the same, like we're just picking a Zookeeper like one of the data center, like a data center 1 or whatever. But yeah, it's any quorum you want as long as all clients can talk to it. So it's up to you. So each cluster has its quorum of Zookeeper, and then basically we're not at this point we're not isolating those clusters with like a third Zookeeper to so basically if like let's say a catastrophic event happened and we're using the Zookeeper in data center 1, well then it's no good, right? We just rolled this out. We're kind of just like really kind of working through some of the bugs of it. But yeah, down the road we would probably want a more isolated Zookeeper from tied to like a data center per se. You just second question you said?
Yeah, I was wondering if you had thought about making a scanner that would just automatically, like as you're iterating, if you get to switch it, then it's like, oh, I'll take the last key value, reset myself up.
Yeah. So his question was, I should have repeated the last one. Hope you guys heard it. His question was basically, wouldn't you just do this in such a way that just everything's happy and you don't get the failover exception? And yeah, totally agree. And we looked at that, but that house cleaning step is super important. I will say when I integrated this Accumulo Failover API into this AFS, so basically let's say GeoWave loved this talk. I don't know if they're here, or Graphulo, and they're like, oh, I want to be able to roll over to any data center. It'd be better on their part. So for instance, this AFS product that we have, so we have a bunch of users, they need this AFS code that they use. We embedded this failover into that API, and it does that. So when they want to persist a file, write this file to Accumulo, if there's a failover, it'll automatically just write it as a new one. If they're scanning, it'll reset. Now I will say that is it's idempotent, right? So those writes are idempotent. But yeah, totally. So it's better to put into the client app you're building is better for that. Any other questions? Sweet. Yeah. So if you guys are interested in this, you can reach out. There is talk of maybe open sourcing this, so we'll see. But it'll be on Bloomberg's GitHub on the outside.